Now let's see an example of how to use random sampling with Python. We're going to use a new dataset for this example called obama2big.csv. This is similar to obama.csv that we saw earlier, but I added a bunch of rows that are just fake generated data to simulate what happens when your data is too big. This file is also in the before folder of the exercise files for this module. In this demo, we're going to create a scatter plot of approval ratings just like we saw in the last video. Then, I'm going to show you how to randomly sample some rows from our data. After importing pandas and pyplot, import obama2big.csv with pd.readcsv. Set the parse dates argument to square brackets, year month, to parse the year month column as timestamps. Put this in a variable called databig. And do the same with obama.csv and put the result in data. Let's make sure that we got the right data with data.head and databig.head. You can see that in databig, some generated data has been added. Let's now compare the size of data and databig. You can find the size of the data frame in the variable data with data.shape. This says data has 1,530 rows and 4 columns. What about databig? It has 65,499 rows and 4 columns. So databig is much larger than data. Let's plot approval ratings from databig against time just like we did in the last video. Remember that the string O says we want to only show points without any lines in between them. Let's set the marker size to 2 and alpha, or the transparency parameter, to 0.3. Show this with plot.show. As you can see, because there are too many points here, the graph becomes just a giant blob and it's hard to know how the ratings are really distributed. In a situation like this, sampling comes in handy. To sample some rows from the databig data frame, you can write databig.sample frac equals 0.1. Frac stands for fraction, and this says sample 10% of the data from databig. Store this in a variable called sampled. Instead of frac equals 0.1, you can also write n equals 10,000 to specify the number of samples instead. Let's plot this sample data just like before with plot.plot and plot.show. Once we plot the sample data, it's much easier to get a sense of the distribution of the data. In this graph, you can see that the approval ratings are clustered around the center of the band, and this is the power of sampling. You've reached the end of this video and this module. I would recommend reproducing this result on your own for practice, and in the next module, we're going to use some of the tools we've learned so far to solve some practical problems.